6 is proving statements about segments and angles. So it's still kind of the same thing. We're still working on this like introduction to proofs type thing. So a theorem is any conjecture that is proven. So we're going to be proving a lot of theorems in this class. A 2-column proof is one that involves like statements and reasons. So we just did one of those on the board. So properties of segment congruence, we haven't really talked about. I mean, we've talked about this a little bit before. So objects are congruent to each other. Measurements are equal. So if you see reflexive property of congruence, it's going to be like segment AB is congruent to segment AB. And then the symmetric would be like if AB is congruent to CD, then CD is congruent to AB. So I think I told you guys I messed that up one time. Like I was telling my class that whenever we saw AB is congruent to BA. Yeah, like I was calling that the symmetric property, but it's not actually the symmetric, it's actually the reflexive property. It's the same segment is congruent to itself, so that should be reflexive. So sometimes I'll just write same segment instead of thinking of reflexive versus symmetric or anything. All right, and then the transitive is the annoying one. So we say if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. So you transition through that middle statement. Okay? So we're going to constantly go between objects being congruent to objects being equal. So I could have, like, the length AB is equal to the length AB. And that would be the reflexive property of equality. But if I go from one statement being congruent to another statement being equal, I can just use definition of congruence. So if I had this as like step 1, and then my next step, don't write this, was like AB equals AB, the reason I would go from one to the other is by the definition of congruence. And it goes both directions. Does that make sense? So we'll have that a couple times in the proofs today. You'll see where we use that. So your textbook sometimes says things like angles or segments with the same measurement are congruent. We're just going to write definition of congruence. Okay. All of the properties in the box are true because we know the properties of equality are true, so a simple example of this is shown below. So it says prove the symmetric property of segment congruence. So I'm never going to ask you this on the test, but here's what we're doing. So if PQ is congruent to XY, that was given to us. So we can say that PQ equals XY by the definition of congruence. We could then say, well, XY is equal to PQ by the, we flip things around, right? So symmetric property of equality. And then lastly, we can say that means segment XY is congruent to PQ. And that's because of the definition of congruence again. Okay, so we don't ever have to do that proof ever again because we can just say that segment XY is congruent to segment PQ because of the symmetric property of congruence. We can kind of combine all of that into one. Okay. So let's try some ones that might be more like what would be on your test. So it says in the figure below, oh man, did my thing get chopped off? It totally did. All right, that's okay, just a little bit. That is a very loud class. All right, in the figure below, prove that EG is congruent to FH if we are given that EF is equal to GH. So we're going to start with what we were given. EF is equal to GH, and we write given. All of you should get this point on the test. If you don't get that point, I will cry myself to sleep and I will write bad comments for everyone. Don't make me do that. All right, we're going to get this right. It's on Friday. So, which gives me the, I get to grade your test before I get to write your comments, which takes forever. Like, why did I do that to myself? All right, so EF plus FG equals GH plus FG. Well, what did I do to both sides of the equation, Cam?
You added something?
I added, so what do we call that? The
addition property of equality.
Yeah, addition property of equality. Because we added the same thing. We added FG and FG to both sides. Anvita's all over this one. She likes this one. EG equals EF plus FG. So do we see it? EG is equal to EF plus FG. And FH is equal to GH plus FG. So what do you think? Yep, segment addition postulate, perfect. Postulate is like a theorem. Postulates don't need proofs, though, because it's like you look at it and you're like, oh, that's easy. That makes sense why that's true. All right, and then substitution property of equality. Well, let's look to see where we're trying to go. We know the last step of this proof because we're trying to prove that EG is congruent to FH. So sometimes if we kind of think a little bit backwards, that helps. So what do we need to get before we can say that objects are congruent to each other? Any guesses? Sophia, what do you think?
So like in number 2, how it says that EF plus FG equals GH plus FG. If you substitute those, you can substitute EG and FH.
Exactly. So I was telling one of my students one day that sometimes if you use like a highlighter and you're like, oh, EF and FG, that's here, EF and FG, so that's equal to this, EG. And they're like, well, that's going to be this, EG, right? All the yellows. And then you're like the blue, GH plus FG. Well, that's here, GH plus FG, and then it's here, right? Well, that's going to be here. So we can say that the yellow is equal to the blue. That's what we need before. We need EG is equal to FH. So that's what she's saying. We're just substituting it in. We're substituting, oh, whoops, wrong color. I can't mess up my colors. Where did my highlighters go? I'm substituting this one into here, and I'm substituting this one into there. Do you guys see it? So we can say EG is equal to FH. Does that make sense? So if you need to use highlighters or whatever, sometimes that helps. All right, so our reason is by substitution property of equality. And then the last step is going to be what? Exactly. We can say that by the definition of congruence. So if we ever need to go from equal to congruent or from congruent to equal, we just do definition of congruence. On a scale of 1 to 10, with 10 being that was so easy, I like proofs. Where are we at? A 7. I'll take a 7. A 5. You're like, why are we writing all these things? Okay, so let's try some more. It's a little bit longer. All right, so it says complete the proof. So RT is congruent to WY, and ST is equal to WX. So I had those two givens. I actually divided them up this time. I put them in different locations. So we have a given here and we have a given here. So you're not getting the points for that because I already gave it to you. So the next one, think about it. How do I go from step 1 to step 2? Yeah, I can.
Aren't you substituting?
Not necessarily substituting. We went from something being congruent to something being equal.
Definition.
Yeah, that's the definition of congruence. Okay, so we're going to write definition of congruence. Okay. Now we have RT is equal to RS plus ST.
Segmentation.
And I went ahead and combined this into one step. So I could have listed it twice. But I just put them in one thing. So I said WY is equal to WX plus XY. Okay, now I'm combining these into one thing. So let's do our little highlighting thing again, kind of. So we have RS plus ST was here. That's equal to RT. Here's RT. Right? And then we have WX plus XY. Well, we have WX plus XY. That's the same as WY. So how can I get blue equals red and then see how I have another blue equals red? Substitution, right? So we did substitution. Substitution property of equality. All right, and then we say, well, given ST is equal to WX. Here's where it gets tricky. So I'm going to give you a couple seconds to think about it. ST is equal to WX. So let's think about it in our picture. So we were given that RT, this whole distance was equal to WY, this whole distance. And we were also given the ST, so this distance here, maybe I'll just write 2 tick marks there. This distance here was the same as WX. does it make sense that RS and XY should be equal to each other then? What did we do? Yeah.
You like took away from number 4. You subtracted the ST and the
Yeah. I just subtract those out, right? That's going to be subtracted, and then I'm left with RS equals XY. Do you guys see it? So it's going to be the subtraction property of equality. So then our last step is we're trying to get that the two pieces are congruent to each other, so we say RS is congruent to XY by the definition of congruence. Okay, a little tricky, right? Colin, pay attention. You said you were at a 5. Don't be at a -3. All right, let's try another one. Okay, RT and PQ intersect at S so that RS is equal to PS and ST is equal to SQ. So we want to get that RT is equal to PQ. Do we have a basic understanding of why that must be true? Yeah, the small one plus the medium equals the big one, right? For both of them. And the smalls are the same and the mediums are the same. All right, so we're going to go through each step. So you have everything written. We just need all the reasons. So RS is equal to PS and ST is equal to SQ. What do we write? Given. All right, then we have ST is equal to itself, ST. Yeah, that's called the reflexive property of equality. Sometimes I write that. Sometimes I just go straight to the next step. So from like here to here. I skip over the reflexive. Sometimes I'm lazy. I shouldn't. What did I do to both sides? I added ST to both sides. Yeah, so that's the addition property of equality. And then it says RS plus ST equals PS plus SQ. So we want to look how step 3 is different than step 4. What's the only thing that's different? ST and SQ. Why could I just replace ST with SQ? Yeah, Rhett? Yeah, because the original one said ST equals SQ, so what's the reason then? Yeah, substitution, exactly. All right, down to 5. RS plus ST equals RT. So let's look how step 4 is different than step 5. Well, we replaced, we're almost there. How do we know RS plus ST equals RT? Look at the picture. RS plus ST equals, that's the segment addition postulate. I should just let you write something like SAP. Some geometry teachers do that. Segment addition postulate. All right, and then RT is equal to PQ. So what's the reason? Why do we think they're equal? So let's look. RS plus ST is equal to RT. PS plus SQ equals PQ. So we're trying to say that red is equal to blue. Well, let's look for more red. We had red here. PS plus SQ, what's that? That's the blue, right? So we're substituting this in for that, and we're substituting this in for that. Does that make sense? So we have substitution property of equality.
Will we get something like this on the test? Or will it be blank?
It won't be totally blank. You'll either have all your statements or you'll have like all the pieces of the proof. I haven't made it yet. I need to. Yeah.
It does really have to write all the names.
You can abbreviate it if you want to, like subst. Yeah. All right, let's try another one. Do you guys want me to pause and you guys try it on your own first? No, you just want me to do it? All right, let's draw some markings in. So the measure of angle 1 is equal to the measure of angle 2. The measure of angle 3 is equal to the measure of angle 4. So why must we know that PQS, or P, what am I trying? PRT, that's it, is equal to QTR. Does it make sense why they have to be the same? Aren't we just doing these two angles, angle 1 and 3, we're going to add them together to get the whole big angle? Angle 2 and 4, we're going to add them together to get the whole big angle? It should make sense when you look at it. When you look at the diagram, you should be like, oh yeah, that's obvious. Now you got to formulate your proof. You got to think about the steps. So we're starting with our given. And we're saying measure of angle 3 equals measure of angle 3. We know what that is. Reflexive property. Usually when we have reflexive property, we're getting ready to add it on both sides. Did I do that? Yep, I added it on this side and I added it on this side. So this is the addition property of equality. So how about the next one? Measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 4. So look at our two steps. Why can we do that?
The substitution.
Yeah, 3 and 4 were equal to each other. So we can replace 3 with 4 or 4 with 3. So since these two were the same right here, we have substitution. Then we're saying, well, measure of angle 1 and 3 add up to be measure of angle PRT. Do we see that in the picture? Do I write segment addition postulate?
No, angle addition.
Ah, angle addition postulate. Good. And therefore, PRT is equal to QTR. Substitution. So if you need to look for the places where they're equal, sometimes the coloring helps, right? So we had all of that. That was here. 2 and 4, 2 and 4, measure of angle QTR. So again, we're back to one where we had red equals blue. So red equals blue. Do you see it? All right, last one. Are y'all proofed out? Long day. All right, M is the midpoint of PQ. What does that mean? What do you think a midpoint means? Divides it in two equal pieces. So I'm going to draw two little tick marks. And it says N is the midpoint of RS. Can I draw the same points? I'm going to do 2 marks right now. But then I was given that PQ is equal to RS. So would that mean that all 4 of them are the same then? All 4 pieces? Yeah, they're going to have to be the same then. So number 1, we're going to have given. Number 2, the midpoint theorem, or the definition of midpoint just says it breaks it into 2 congruent segments. So you would say like, so let me write this here. So definition of midpoint says that like PM is congruent to MQ. That would be a definition of midpoint. But the midpoint theorem, and I don't even think your textbook calls it the midpoint theorem, but just a lot of geometry teachers will call it this, is that PM is equal to half of the PQ. So a definition of midpoint is that it breaks it into 2 congruent pieces. So like this is equal to that, like congruent to it. And the midpoint theorem does the 1/2s. You can see these 1/2s. So for number 2, we're going to say midpoint theorem. I probably wouldn't count it wrong if you said definition of midpoint, but I'm really not that picky on these. All right, and then we have another given, PQ is equal to RS. And then 4, why do we think we can say half of PQ is equal to half of RS? Not substitution. What do we do to both sides? How do we go from step 3 to step 4? We divided by 2, right? Or multiplied by 1/2, either way. So I'll say multiplication property of equality. Oops, multiplication property of equality. So we multiplied by 1/2. And then the last step is substitution. So see, the half RS was here, and then we had the half PQ was there. So this one's blue, this one's red. So RN Did I ever have blue equals red though? Did I do that? PQ. Oh, I guess I did. I had blue equals red with a half PQ equals half RS. So yeah, those are blue equals red. So this is substitution. So I was basically substituting PM, or 1/2 PM in for half PQ and RN for half RS. Does that make sense? Do you guys get it? Okay. So I think you guys have more, but these are the ones that I'll definitely put these on the test. These are not like actual full proofs. So I want you guys to test yourself. So as we're going through, think about if you can get it. So 6x minus 7 equals 29. Why would 6x equal 36? So I'm going to call on you guys. So what do you think, Grace? What did we do? Right, we added. So we're going to say addition property of equality. All right, Colin, I'm coming your way. 3 times x plus 2y equals 3x plus 6y. Why is that true? What do we call that?
Oh, it's the distributive property of equality.
Distributive property of equality.
Never mind.
Oh, well, we don't need to say property of equality, actually. We can just say distributive property. Because we're not doing it to both sides of the equation. All right, Koshal, what do you think? Measure of angle A plus equals measure of angle B. Measure of angle B equals measure of angle C. Then measure of angle A equals measure of angle C. Transitive, and is this of equality or congruence?
Equality.
Yep, because they're all equal signs, right? So transitive property of equality. AC equals AC. Mackie, what do you think? AC starts with an ER. Reflexive property of equality. All right, if angle A is a right angle, then measure of angle A equals 90. Cassie, what do you think this says?
Definition of right.
That's totally what it is. I was trying to trick you. Definition of a right angle. So it's one that we haven't really used yet, but we know that. Colin put it away. All right, if M is the midpoint of AB, then AM is equal, I should say, let's do congruent. That bothers me. Is congruent to MB. Yeah, what do you think?
Midpoint theorem.
I'm going to say definition of midpoint. The midpoint theorem is really the one that has the 1/2s in it, but
Would it count?
yeah, I'd probably count it. All right, good? Makes sense? All right, so number 7, in the diagram on the left, angle AOC is congruent to angle BOD. So AOC, this one, is congruent to BOD, this one. Rhett, what do you think? It's congruent by what? I would say by vertical angles, or vertical angles theorem. And measure of angle AOC is equal to BOD by the definition of congruence. So once you have the first things true, then you can say definition of congruence on the other. All right, if AB is congruent to XY, then blank equals blank by the symmetric property. So let's see. Joseph, you got this one?
Segment XY is congruent to segment AB.
Perfect. Good job, guys. All right, AB equals CD and XY equals XY. Then blank equals, then what happens by the addition property of equality? Jada, any ideas? This is a weird one.
It would be then AB plus XY equals CD plus XY.
Perfect, yep. Do you guys see how you can add XY to both sides? All right, AB plus BC equals, Maya, you think you got it? By the segment addition postulate. So A to B added to B to C equals what? Not that one, down here. So I drew it up here. So Maya, look, A to B plus B to C equals the whole distance. So we'd say A to C by the segment addition postulate. And the measure of angle ABC plus the measure of CBD. So if I had A, B, C, and then I had C, B, D, so this angle plus this angle equals angle A, B, D. Perfect. Does that make sense? You guys get it? Would you guys be able to do those?
Yes.
All right. I'm going to stop there.